On the MayFly bench today, this old Marshall Master Volume lead amplifier. The complaint with the amplifier is that even at low volume, it stops working after about 6 minutes. The owner indicates that it's running, but then the indicator light goes off and the amp starts making sound. Let's open it up and see what's going on. With the Marshall on the bench, we find something I did not expect, a printed circuit board. I guess they must have switched to those in early 70s, but that's the genuine Marshall article. Some scary things you can see right here. Someone has been messing with the solder in a couple of points here and over here. Points to a past removal of this circuit board for some reason. So we're going to gently power the amplifier on. You can see I've got my handy power soak as a speaker load. And we're going to power it through my dim bulb tester. This has the advantage that it controls the current rolling through it. And I can also see how much current it's pulling. Here we have the Marshall powered up after a brief warm-up. We're monitoring part of the DC B+ rail, and of course it's plugged into our dummy load. We're also monitoring mains current. It's about 1.5 amps right now, which is a lot for a amplifier at idle. After some time, we've noticed that the mains current has creeped up to 2 amps. Keeping a close eye on that. After running the amplifier for a little while, the mains current creeped up to around 2.5 amplifiers. So something is drawing more current as the amplifier gets warmer. Now we're going to do some fault finding to figure out exactly what that is and correct the problem. On closer examination of the bias circuitry, it turns out that the bias being generated right here, these 2 points that make its way over here through these resistors to the output tubes. Measuring that even in the best conditions ends up being minus 38 volts. Schematic says it should be minus 60 volts, 63 to be exact. So we've got deviation. So I went through and I checked all the resistor values. They vary a little bit from the schematic, but they match the component values that are actually encoded into the color code onto the resistors themselves. So the resistors have not drifted from what was installed at the factory. So something is drawing down that voltage, and I suspect capacitor leakage. It could either be these decoupling caps from the bias circuitry, or these coupling capacitors that couple AC from the phase splitter. Because on the other side of these guys, it's the full B+ voltage. And if these guys are leaking, it'll pull up that bias voltage. Welcome back. It's about, I guess about a half an hour's work at the soldering station. The board is flipped upright. I decided to remove the connections on the preamp tube side, which exposes the back side of the board, so I can have a look at the components in question and determine if we need to be replaced. New components are in place. New coupling capacitors. Up the capacity a little bit because I had them, and if you can have more decoupling on your bias circuit, why not? And a couple of very nicely brand new 0.022 microfarad capacitors for the phase splitter. All of the solder connections have been reattached. Well, our suspicions were correct. Measuring the bias voltage now that it's all tweaked up, getting a nice minus 50 volts, which is a big improvement from our minus 38 volts we had last time. Well, with a set of power tubes installed, everything warming up, we've got minus 50 volts in the bias, and more importantly, we're drawing only about 1 ampere of AC power. So next step is we're going to let this run for a good 20 minutes or so. We'll pronounce it fixed, and then we'll adjust the bias properly, and we'll see how it sounds with the guitar plugged into it. All right, we have our test bench set up. First we have a signal generator set to 1 kilohertz, plugged straight into the input. We are monitoring that input on the oscilloscope, which is the yellow line. The blue line is the output, which is flat because the amplifier is turned off. We have one output hooked up to our dummy load. The other output is hooked up to the oscilloscope. We're going to turn on and see what happens. All right, we are ready to go. We're monitoring the input, and the output is the blue line, which is set at 10 volts per division. So we're just flipping it off standby here. All the EQ is set to flat. Going to give a little bit of preamp volume, a little bit of master volume, and we should get something. Oh, there we go. We have output, so that's 20 volts peak to peak. As you can see, we do have a little bit of crossover distortion. We're going to turn it down a little bit. Going to find myself a probe, and we're going to adjust things very carefully, try and eliminate that crossover distortion. Alright, we've done some bias tweaking. I don't want to go too far with this. As you can see, the crossover distortion is considerably better. And bias voltage is 47.5 volts. So if you recall, the original complaint about this amplifier was it would shut down in about 6 minutes or so. So we're going to leave this running. We're going to give it a good test for about 20 minutes. Well, it's been 20 minutes of running. Bias voltage is stable. Mains current is stable. Output waveform looks good. Tried both inputs, low sensitivity, high sensitivity, and ran it all the way up to 100 watts. Everything seems to be fine. Looks like it was a bias circuit problem, specifically some leaky caps. So, after this, we're going to shut it down, go have some dinner, then come back and hook it up to a cabinet, see what it sounds like.